Topic is for grade 9 students, still on the nature of roots of the quadratic equation ax squared plus bx plus c equals to 0. This time I'm going to give the definite rules in describing the nature of roots of the quadratic equation ax squared plus bx plus c equals 0. So we have definite rule number 1. If d or discriminant of the quadratic equation is equal to 0, there is just one real root of multiplicity 2. Definite rule number 2. If discriminant d of a quadratic equation is greater than 0 and is not a perfect square, there are two real roots which are irrational and not equal. Definite rule number 3. If discriminant d of quadratic equation is greater than 0 and is a perfect square, there are two real roots which are rational and not equal. Definite rule number 4. If discriminant d of a quadratic equation is less than 0, there is no real roots. Where we have discussed discriminant d equals to b squared minus 4 multiplied to a multiplied to c. Example. Question number 1. If the value of the discriminant of a quadratic equation is 1, then how many roots are there? So remember that number 1 is considered a perfect square because 1 times 1 is 1. So therefore 1 is a perfect square. So this question falls on definite rule number 3. If d is greater than 0 and is a perfect square, there are two real roots which are rational and not equal. So the answer is there are two real roots, but these roots are rational and not equal. Okay, so for number 2 question, if the discriminant of a quadratic equation is negative 1, how many real roots are there? Again, this question number 2 falls on definite rule number 4. If discriminant d is less than 0, there is no real roots. So what are we going to write is 0. There is 0 or no real roots. 0 real roots or no real roots. Okay, so I hope you understand my discussion.